Good man. Let's go ahead and get started then. I'm sure we'll get a few more people and hopefully a clicker will magically appear for me. So welcome to MBL201, Mobile Game Architectures. This is a session all about building mobile game backends on AWS, so now's the time to double check you're in the right place. So you're not looking the whole time through your program wondering where you're at, like any wedding you've ever been to. So my name is Nate-Wiger. I'm a principal solutions architect, and my focus at AWS is all about working with gaming customers such as yourselves. That's actually my background as well. Prior to coming to AWS, I was actually at Sony PlayStation where I launched a number of AAA titles on AWS starting in 2008. I was actually on the Amazon advisory board for a number of years. So now that I'm at AWS, I've been here a little over a year. I've had a lot of great opportunity to work with a lot of mobile game companies worldwide, doing lots of really cool stuff, mobile, AAA, MMO. And what I'm hoping to do today is share with you some things that, common patterns that we're seeing basically across the board. First, from an industry perspective, it's probably a lot of stuff you guys already know, but it's good to just level set, sanity check, get us all on the same page. And then we're going to go through an iterative approach of starting small, building up a mobile game from scratch, and really taking advantage of one of my favorite properties of AWS, which is the fact that it's all about individual services that you can mix and match. So we're going to start small, kind of go through as our game gets bigger and bigger, things we can do to scale it out, and then talk about a couple other things, push messages, which are huge, very important for mobile gaming. Obviously keep people engaged, bring them back into the game, and then talk about analytics at the end, last but certainly not least, but an extremely important part of mobile gaming. So before continuing, just a quick slide of a few, the logo slide, you always got to have one of these. But some cool highlights on here, Supercell doing some really great stuff on us with Heyday, Clash of Clans, Rovio, Angry Birds, everyone knows them, everybody's bought the plush doll, I'm sure. But their recent case study we just published. TinyCo, Wooga, lots of well-known names, Half-Brick with Fruit Ninja. So lots of mobile companies doing some really interesting stuff. So we'll talk about little stuff that's common between these companies. So free-to-play is obviously the dominant means right now, combined with in-app purchases. That's basically where the business model is at. And it's all about the long tail, all about keeping users interested, keeping them interested, growing, going cross-platform. And before it was iOS, 99 cent. Now over the past few years, we've seen very much as iOS and Android, free-to-play, in-app purchases. And then once you've established a user base, maybe in a specific region, it's all about taking that user base and going global. If you're successful in the States, that's great. Take it to Europe or vice versa. Trying to get as many users on your game as possible. Because it's all about retaining users. The longer you retain users, the more revenue you're going to make. If it's in-app purchases, microtransactions, 99 cents here or there, the longer you can keep them interested in the game, the more money you're going to make per user. And this is a slide, this is from Gartner, but there's quite a few people saying the same thing just to kind of drive this point home. This is kind of one of those crystal ball, take it with a grain of salt, but the basic projections that people are saying is that in terms of paid apps, it's pretty much flatlined at this point, and all of the revenue is going to keep coming from in-app purchases and ads. So what are some things that you're going to do with your game in order to be able to turn those kinds of business and design goals into actually technology features that you're going to actually have in your game to keep people interested? Well, it's all about social login, friends, leaderboards, competing against your friends, one-upsmanship, all that kind of mechanism that you guys are familiar with in order to keep people engaged. And then push messages, as I mentioned, saying, hey, so-and-so just beat you, come back in. And then content updates, Halloween pack, something else, Christmas-themed asset, anything you can do to keep the game feeling fresh. And all of that's got to feed into your analytics. You've got to be doing analytics constantly on this. Otherwise, you're just kind of throwing stuff at a wall, seeing what sticks. You've got to know why people are buying stuff, what they're buying. Are they buying the strawberries? Are they buying the blueberries? It's a critical part of it. Analytics really is the lifeblood of your game, so we'll talk about that. A couple highlights. This is kind of AWS core value prop. A lot of you have seen these slides, no doubt, before, but I like them personally. They still resonate with me as one of the reasons I started using AWS as a customer in the first place. And that is, if you're making a game, games are very hit-based. Right? You never know what's going to be the next big thing or not. If you're making big bets, you're buying a lot of hardware, you way overspend. If a game you think is just nothing and it takes off, then all of a sudden you've got customers that are very unhappy with you. Being able to dynamically scale up and scale down, huge part of the reason why AWS is so popular with gaming companies. And this is a real-world example, actually. This is from Dev Sisters. It's literally one guy does the game Cookie Run, huge in Korea. And this was a 24-hour segment where Apple ran a promo on his game, unbeknownst to him, and it basically went viral overnight. And so he leveraged auto-scaling, AWS properties, and was able to actually trend up, spin up instances, spin back down instances, completely automatically. And we'll talk about that. Go global. A lot of you have seen this slide, but just to highlight, we do have 9 regions worldwide: US, Europe, Asia Pacific, South America, Brazil. And it's all the same API, right? You start out in the States, you start out in Europe, you decide, hey, the game's going really good, and it turns out that people are interested in Korea or wherever, or in Singapore. Use the same API, spin up your servers in Singapore, and away you go. Cool. So as I mentioned, Supercell, hugely successful, got some amazing games. Clash of Clans, heyday, they're running on us. They're really pushing AWS to its limits, doing a lot of great things. So what does a back end for a game look like for something like this? What does it mean from a technology perspective? So there's a couple things, core tenets of the way you're going to build out your technology, right? First of all is you want to use HTTP as much as possible. Now, in the old days, if you've been around the gaming industry for a while, it was all about stateful TCP sockets, long-running server processes, and there's absolutely still a use case for that if you're building a real-time multiplayer game, right? If you're building a game where you're running around and it's a first-person shooter or something like that, then you need some amount of that in order to send multiplayer packets. But the point is use that sparingly. Use that when you actually need that if you are doing a multiplayer game. If you're not doing a multiplayer game, you could argue you don't really need it at all. So do as much as you can in HTTP. Along the same lines, you're going to be interfacing with a lot of social APIs. Those are also HTTP. It just makes it easier to scale out, scale in, dynamically replace instances. You don't have to worry about maintaining state and migrating users between servers. You're going to need some way to save state on the server if people are making in-app purchases and their device gets wiped, or they're playing on their iPhone and they go over and they want to play on their Kindle. They're going to want to pick up where they left off. So you're going to want to save that state on the server. It's going to require some kind of database. Some of this is pretty straightforward to understand. You're also going to need a place to store your static data. Static data meaning all your game assets, stuff that really doesn't fit in a database. You don't want to jam a whole bunch of binary game assets into a database. You can do it, but it's probably not going to be very fun, and you're going to really stress your database out. You want to save your database for stuff that actually needs to actually do relational data and transactions, that kind of stuff. Mobile push, a way to implement those push messages. And then analytics. You're going to need to tie this all into analytics. You're going to have analytics in your platform. So let's go through this. Let's start out and let's say, OK, this is great. Understand the ideas. How do I actually do this, right? So step one is you just want to choose a region. This would be by where your users are probably going to be. We've got 9 globally, right? So let's say you're going to choose Oregon, for example. So you choose Oregon. And then for development purposes, you're just going to start out and just going to choose one availability zone. So in all of our regions, we have at least 2 availability zones. If you're not familiar with the concept, availability zone is just like a data center. They're all designed to be independent from one another. So the idea is if one availability zone explodes, then the other one keeps running. So that for production, which we'll get into in the next slide, you're going to want to make use of multiple ones of these. For development, we'll just start out with one. We're trying to keep costs low. And we're just going to spin up an EC2 instance, straightforward stuff. And that's where we're going to put our app code. And then we're going to put an elastic load balancer in front of that. Now, you might be saying, well, this is kind of silly. We only have one instance. Why would I put an ELB in front of one instance? There's a couple reasons why I'd encourage you to do that from day one. First of all, it just gets you in the habit of working with a load balancer in front of your app. It's a minuscule additional cost. It's basically free if you're talking about the amount of traffic you're going to push in development. And there's going to be different ways you're going to configure your EC2 instance if you were to directly connect to it versus if you were to go through load balancer. It's better just to do that in development, get used to that pattern, and then when you actually go to production onwards, then it's the same pattern. You don't have to say, oh, wait, I have to make some changes right before I'm about to launch. And then finally, you're going to need a database. So RDS supports MySQL, SQL Server, Oracle. Great option. We'll talk about some other options in terms of NoSQL offerings. But if you're just getting started, this is about as simple as you can get. And this really is kind of the nucleus of what you're going to be doing for a game. As we go through these slides, you're going to see a lot of other services added on. But at the end of it, it all comes back to this, right? This is where the bulk of your stuff is going to happen. You're going to have an HTTP-based API, talking JSON to your server through your load balancer. You're going to be saving stuff in your database. And that's kind of where most of your functionality is going to reside. So that works really well for development. Oh, sorry, I meant to mention, won't spend a lot of time on this, but the social APIs that I mentioned earlier, those are just kind of be over to the side. That's not something you own. But you're going to be interacting with those both directly from the client, and you're also going to be talking to them from your EC2 application tier. So that's just kind of how that fits in if you want to visualize it. We won't really talk about that much. So you're getting ready for production. You say, OK, development's working great. I'm getting ready to launch. What do I need to do to actually make this ready for production? So step one is you're going to want to use another availability zone. Real simple. Keep it simple. Don't overcomplicate it. If you started out and you put everything in availability zone A, then just spin up availability zone B as you're getting ready for production. Spin up another EC2 instance. It's going to look the same. It's going to function identically to the first one. You're going to add it to your load balancer. You're going to be ready to go. So that handles your application tier. What about your database? Well, if you're using RDS, there's a functionality called multi-AZ. Many of you have heard of probably. And that is, it's literally just a checkbox when you're spinning up a database. You say, OK, I want this to be multi-AZ. And what that does is that spins you up a secondary. So you have a master, you have a secondary database, and another availability zone. Again, the idea being is that if the availability zone on the left just completely explodes, you've still got your secondary. RDS will handle failover for you automatically. Your application will keep running. It's not going to get interrupted. And then the last thing, we talked about static content. So when we're getting started in development, we can potentially skip this, or we can add S3 at the start. But S3 is definitely something you're going to want to make use of as you're looking to go live. So it's an HTTP-based file store. You put and get files to it. You don't have to pre-allocate it. You can just put as much stuff in as you want. You pay per gigabyte per month. And it's a great place to put stuff like your static game assets. If you're doing a game that has user-generated content, if you've got avatars or other stuff people are allowed to upload or customize, that's a great place to put stuff as well. Since it's HTTP, going back to the earlier point about using HTTP as much as possible, so you've got a client that's already talking HTTP, it's already talking to your RESTful servers on EC2 through your load balancer, and then you just make HTTP calls to S3. It's all the same, right? You put your static files up here, you put your dynamic data there. It's all the same pattern there to make use of. So it really helps simplify things when you're talking about the way that you actually program this from a game client perspective. So that gets us in pretty good shape for launch, but what do we actually do if we actually have millions of users? We have a game like Heyday that has millions of users a year, or a day rather, sorry. And what do we actually do to get to this really massive scale? Well, the great thing is if you're following this approach, same thing with something like Uncharted, millions of copies sold, right? Then there's not a point where you're going to have to start over and say, oh, I've reached the limits, I need to throw everything away. You just keep adding on pieces to this. Next piece you're going to want to look at is auto-scaling. Straightforward, probably a lot of you have heard of it. CPU, for example, you can trigger off CPU. If CPU hits a certain percentage, spin more instances up. And this is the methodology that DevSisters used. And then you're going to want to look at caching, right? Another key part of any scalable architecture. Elasticache is our managed cache. You've seen a couple times I put or DIY in the slides. And the thing I like to emphasize is with a lot of these services, RDS, Elasticache, what have you, you can always just spin up an EC2 instance, any version of Linux or whatever you like, install memcache or install MySQL on it and manage it yourself. You always have that flexibility. In practice, the nice thing about stuff like Elasticache and RDS is that it takes care of a lot of that really mundane administrative stuff for you, managing configuration, adding nodes, removing nodes, stuff that you can all do yourself, but it's all stuff that takes away from the time that you could be spent making your game, right? And that's what's really important. Nobody's going to buy your game because you have an amazing cache management infrastructure, right? Nobody goes to the App Store and says, hey, I heard those guys really know how to manage their memcache layer, right? Yeah. It's never going to happen, right? And so the last piece that's absolutely important is a content delivery network. CloudFront is ours. If you've never used a CDN before, you might think, oh, that's only for video downloads or whatever. It's actually very important for gaming for a number of reasons. So historically, there's always been the case where people are downloading updates, downloading new levels, as I mentioned. Maybe you have Halloween-themed assets, right? That's all the kind of stuff that a CDN is great for. And what a CDN gives you is you get edge locations that are closer to clients, right? They get less latency for downloading. It's a better user experience. There's actually an inflection point if you look at the way the pricing works out, where it actually becomes cheaper once you pass a certain amount of volume to serve it through CloudFront than directly through S3. So you actually do save money at large scale. But beyond the download piece, I want to highlight something that just came out a few weeks ago, and that is we just added post, patch, delete options. But really put, post, patch, delete, those are the main ones. Support to CloudFront. What that means is, in addition to just doing GET requests, right, you can actually put content up through CloudFront. So the same way that you've been developing your game from day one, you're using S3 to put maybe user-generated content up. When you go live, then you don't have to change your game client at all. You just put that content up through CloudFront. And then CloudFront actually takes care of then proxying that back and putting it in S3. Now, why is that cool, or what does that really get you? So it's all about the last mile, right? I mean, the problem with mobile devices especially is that network connectivity is really flaky, right? It's really not that great. You've got 3G, 4G, LTE. Users are in their car, switching between these, right? So the cool thing about using CloudFront for that layer as well is that it really helps you with that last mile. Users are not having to put from their remote, location down in Florida up to a bucket in Oregon, right? Where who knows what can happen between there. They hit a POP that's closer near them, and then we take care of, from a backbone perspective, sending that content off to S3. And this is, representation of where our POPs are. We keep expanding. There's, more and more connectivity, as you'll see, in South America, Asia Pacific, so it really helps with those regions especially. So we talked about different companies that are using us. Ubisoft, in addition to Assassin's Creed, Far Cry, they actually used us to launch 10 games in 18 months, which is actually pretty impressive being a game developer myself. And then Cookie Run, as I mentioned, this is Dev Sisters. This is with a one-man team, essentially, that's scaled up and down overnight. So if we looked at the past slides, there's some cool stuff there, but to me at least, it still seems like quite a bit of work. And me being a game developer, and probably many of you as well, just want to focus on making a game. So I want to talk to you about Elastic Beanstalk. And what this does is it really helps simplify the architectures that I outlined so far. So what Beanstalk is it's a managed container for AWS, meaning that you take your code, you can do a git push, you can do a zip upload, a WAR file, et cetera. And from there, Elastic Beanstalk as a management service will actually take care of spinning up that ELB, spinning up your EC2 instances, setting up auto-scaling rules for you, setting up your RDS database, all the stuff that we outlined, Beanstalk will actually do that all for you. You'll get a web dashboard that shows you the current version of code that's on. It organizes it. You can have applications, and then within applications, you have different environments, and you can actually move code between them. So there's some pretty nice things there. You also have the ability to swap URLs when you're doing a deployment, which effectively gives you zero downtime deploys. You essentially have two environments. You deploy to the new environment, and then you flip the URL, and then you don't have any kind of interruption to your users. If you've ever tried to do that on your own, you know it's quite a bit of little work to actually make that work right, and Beanstalk will handle that for you. And then a key thing about this that I want to drive home is that there's no penalty, there's no weird proxy layer, you're not in some weird strange part of AWS where you're going to hit some kind of downside to using this. It's literally just kind of, I think of it as a macro, right? It'll spin up all this stuff, and when it's all done, it's the same ELB, same EC2 instance, same RDS stuff that you would have if you were spinning it up yourself. You can still log into the instances as root, so you're not really losing anything. And if it were me, I would definitely use it, right? Like if it was me building a game, to me it's a no-brainer, right? And how does this fit in then to our diagram? Basically, Beanstalk just wraps around that whole core that we talked about, right? It's just a container that just wraps around that. So all that stuff inside that green, rather than you having to do that and manage that yourself, you go into Beanstalk with a few clicks or with an API call. It'll actually do all of that stuff for you. And then any other services you're going to use along with it, S3, CloudFront, et cetera, those work just the same as you would. They just work in conjunction with your other EC2 resources that you've spun up via Beanstalk, so there's no difference there. And I kind of glossed over, but that little extra icon in the upper right, that's monitoring, that's CloudWatch. That's, again, something that Beanstalk will set up and configure you for free. You can do it yourself in terms of setting up alerts and such, but Beanstalk just has a nice way to wrap that all together, give you some monitoring out of the box. And this is a snapshot. Our console keeps changing. This is from a couple days ago, so this might have changed since then. But in this example, you can see this is a Ruby app. It supports Ruby, Node, Python, PHP, Java. Oops. And so you see that you have the little spinning icon that tells you it's booting, et cetera. And so you get the idea. The last thing I want to mention about this is that this is not like beginner AWS. This isn't like training wheels for AWS, and once you use this and you learn how to use AWS for real, and the next time you just do it natively, right? There are like some serious games that are using this. If you have a chance to see the Killzone talk, I actually know the guy who's giving the talk from my days at Sony. It's going to be awesome. Killzone, which is launching on PS4, Shadowfall, is actually entirely in Beanstalk. So some serious games are using this. This is not just a small beginner service. All right. So this is Halfbrick's Fruit Ninja. Talk a little bit about databases. So databases are a problem for games, right? Fruit Ninja, as well as others, ran into issues. And what are those issues? So games are very write-heavy. And this is very different than a lot of other web-based applications, right? Your typical web-based application is very read-heavy, right? You're doing some kind of publishing of content. Most users are coming to consume it, read, et cetera. So a lot of caching and a lot of MySQL optimizations and stuff like that that benefit games or benefit web apps are not as useful to games, right? Okay? When you think about the stuff that you're doing to your database, I don't know, it's on auto mode now for some reason. Sorry. When you think about the stuff that you're doing to your game, to your database, right, you actually find that you're not necessarily making use of a lot of the relational features of a database, right? You're doing a lot of little updates, right? Hey, this user just unlocked this item. This user just got this new high score. He just completed this level. So it's a lot of key value, key value, key value. You're hitting the database a lot. You're forcing it to do a lot of database syncs, right? And you're also contending with binary data. Now, large binary data we already talked about. Yes, you're going to stick that in S3. That's the obvious place for it. It's cheaper. It's better. It's more scalable. All that. But there's small little pieces of binary data that may make sense, like a little bit mask or something like that to store in your database. Databases really don't like this. And so what you're going to find very quickly is that your database is going to become your bottleneck more than anything else, right? And this is not a limitation of anything necessarily RDS or otherwise. This is just the way MySQL has evolved. It's a property of relational databases. There's a whole bunch of stuff that relational databases do, transactional integrity and all that kind of stuff. Not that important for games, but it really restricts just how many writes you can push through a standard relational database. And this is exactly the problem that Halfbrick ran into with Fruit Ninja. Their game was wildly popular, and they just found that their database was just completely falling apart. So what Halfbrick did, and what a lot of gaming companies are doing, we're seeing very strong uptake here, is look at Dynamo DB. So if you've ever heard of any other key value type databases, Cassandra or Couchbase or such, Dynamo DB is the same kind of concept, right? It's a NoSQL data store. So you don't have relational concepts, right? You put and you get keys and values. And this, like S3, is a service, right? It's a fully managed service. It's not something that you're going to deploy in an actual availability zone. Hold on, this thing keeps advancing. It's something that we take care of the management for. You get an endpoint API, you put and get keys from it, and then we take care of the rest. And so you say, okay, well, how do I actually tune it? It uses the model of provisioned throughput. And what that means is you go into DynamoDB, you say, hey, I want 300 writes a second, and I want 100 reads per second. And then we take care of sharding it in the background, spreading it across SSDs, take care of splitting up the data in order to deliver that throughput to you. Okay? It's completely hands-off for you. If it turns out your game is growing, then you need to do even tens of thousands of transactions a second. We can accommodate that. You literally just go on through the API and just configure it. And secondary indexes is something we recently launched. Local secondary indexes gives you even more flexibility. So I would definitely encourage you, if you haven't looked at DynamoDB, or maybe you did a little while ago and said, oh, okay, well, it doesn't have X or Y feature that I would need, definitely take a second look. I think there's a lot of compelling things, and it really matches the game use case quite a bit in most cases. And so kind of tying it all together, so it talked about Beanstalk, how would that fit in? So essentially, Beanstalk is going to wrap your application part, your EC2 instances. It's going to handle the auto-scaling for you. It's going to handle your ELB. Then you just point it at your DynamoDB table that you've created, point it. You configure through Beanstalk to just inform it about your S3 bucket. And so pausing on this slide for just a second, again, the kind of, if it were me, my personal opinion, if I was building a mobile game, this is absolutely where I would start. Maybe after testing this out, if you find, hey, DynamoDB isn't going to work for me, I really do need certain relational properties out of MySQL, then you can just switch that DynamoDB piece to RDS. That's fine. We already went over that. You can use Beanstalk with RDS, no problem. Totally works. But if it were me and I was starting, this would be my starting place. All right, cool. So we've covered the core architecture, scaling it out, what your actual services look like. Let's talk about push messaging, right? You've got something like Angry Birds. You're popping up notifications saying, hey, come back and play. Such and such is happening, right? What does that look like? So we've got simple notification service. This, again, is similar to DynamoDB, similar to S3, is a managed service. It's not something that you would spin up in an AZ. You configure it. It's got the concept of messages and endpoints, right? You send a message into it, and then you can choose an endpoint. You can send it out via SMS. You can send it out via mobile push to have it wind up on an iOS device or Android. So an example would be somebody beats the score on EC2 and say, hey, Fred, I just beat your score. Check this out. Send that to SNS. SNS knows that Fred has a iPhone 5 at whatever, and we'll actually forward that on to Fred. Fred gets a pop-up. He comes back and says, oh, Nate, I'm going to beat you this time. So SNS is useful outside of just mobile push as well, right? You can tie other things into SNS to forward notifications. And one of those examples is CloudWatch, the monitoring that I mentioned earlier on. Regardless of whether or not you set it up yourself or used it via Beanstalk, you can set up CloudWatch to actually send notifications when certain things happen. Say your database is seeing a certain amount of write latency. You can send that alert through SNS. You can say, hey, if this kind of alert comes in, send it to my cell phone. You get it on your cell phone. And then you're able to take action on that. You're able to say, wow, something's happening. I'm going straight to the pub, right? Hopefully not, but you get the point, right? So in order to avoid going to the pub and just drowning your sorrows away, right, as your game is becoming successful, there's some more interesting automation things we can do with SNS as well. So take a quick detour. Let's talk about different service. SQS, no doubt heard this. Simple queuing service. Real easy. You just add messages to the queue, and then you can have workers pull those messages off. It's a great service, very easy to understand, scales very, very horizontally, et cetera. So it's great for background tasks. When you're first starting out developing, you might do some of this stuff in your web tier, right? Somebody uploads a new avatar, so you resize it. That's fine when you have a few hundred users. When you have a few thousand or a few million users, you're going to be bogging down your application tier unnecessarily. So what you'll do, some guy uploads a new avatar, you'll have your client send that binary data to S3. We already covered that. But they're also going to stick a piece of metadata, say, oh, here's my user ID, and I just uploaded a new avatar. That kind of stuff is going to go through your web tier. But then rather than having your web tier resize that avatar, you stick a message into SQS, say, hey, so-and-so just uploaded new avatar. Could you go ahead and generate some thumbnails so that other people can download it and take a look at it? And then you can have your background job workers, which are just another set of EC2 instances, take care of that actual resizing for you. There's some interesting stuff I won't have time to cover now, but I'm going to direct you guys at the end to some other talks for kind of more information. There's some really cool patterns you can do with SQS in terms of spawning background jobs and decoupling a lot of stuff. So it's definitely something that if you haven't looked into SQS that much, I'd recommend you looking into more because there's some really kind of cool stuff you can do with it. So we process that, bringing that full circle to what does it mean for a game. So let's move from the avatar example to like a score example. Previously I said, hey, Fred, I beat your score. Come check this out. Well, maybe I want to do some additional processing in the background. Maybe I want to re-rank leaderboards. Maybe I want to say, oh, OK, now your new rank is this, et cetera. So do that through my background workers. And then I can actually trigger another SNS message. Right? I can say, hey, Fred, beat your score. That gets forwarded on to Fred. Fred says, oh, Nate, I'm going to beat you this time. Right? So that kind of shows you the kind of full circle when you're using SQS and SNS together. Again, either of these you can use one or the other. You don't have to use both. Just to reiterate, I mean, my perhaps favorite thing about AWS is the fact that these are all a la carte, right? You don't have to, in order to use SNS, you don't have to use SQS and use these 5 other services. You can choose one or both or neither, right? And you can just evolve. As your game grows, you can add stuff that makes sense. Okay, so last thing on this. Last kind of interesting pattern I wanted to talk about would be SNS then feeding back into SQS. So we saw how we can actually feed out through SNS. But we can actually send stuff in through SNS as well. Something arrives in an SNS topic, and we can actually connect that SNS topic to an SQS queue. Why would you want to do that? Well, think of something like monitoring. Monitoring sends that alert. It says, hey, such and such is happening in your database. You're seeing extra latency, et cetera. You can actually send that to SNS. That'll get propagated down to SQS. You can have your background workers do some kind of action. Maybe they're either going to do something directly, call an AWS API call to add additional capacity, or they're going to just kind of back some stuff up, queue some stuff up. Again, there's some interesting patterns there. And then you can still have it, in addition, send it to you at the pub, right? Hopefully now this time you're enjoying a beer, celebrating the success of your game, looking into how it's #1 on the App Store. And it's like, hey, FYI, we're spinning up new instances. And you're like, sweet, have another better. Rounds around me. OK, so last major thing I wanted to talk about, analytics. Right? You have a successful game. Why is it successful? What's going to make it continue to be successful? What are people interested in? If you wanted to add another level, if you wanted to add additional content, what's going to draw people in? What are they going to buy? Like, how do you know, right? I love this, Dilbert. I thought this was completely appropriate, right? So without analytics, I mean, this is basically what's happening, right? You're guessing. You're saying, I don't know, right? So we don't want to be in that position, as hilarious as it is. So when you're first starting out, you're probably going to look at off-the-shelf analytics. There's a number of packages out there. There's a lot of reasons why they're compelling to start with, right? They're easy to integrate. They've got some pre-baked reports that you can just get going with. But as you grow, you're going to find, well, the pre-baked reports are actually kind of a limit. I'd like to slice the data up this other way, and I can only push in so much data a day, and then they're only going to retain it for 14 or 30 or 60 or 90 days. And then my data's kind of stuck in that system, so what if I want to take a big dump and I've got gigs or terabytes of data? And so what we find is that as gaming customers grow, very quickly they want to own the data themselves. They want to be able to run their own analytics, be able to have the data, slice it and dice it however they want to. So how do you do that in the context of AWS? So we've got our core architecture here, right, that we've set up, that we're running, game's running great. We've got two options. The first option would be Elastic Mapreduce Emr, which is just managed Hadoop. I'm sure you've heard of it. For many years, it was really the only option. It was the only thing that we ran natively on AWS. Still a good option. But you have to think in the MapReduce mindset, right? You're not able to use a lot of off-the-shelf tools. You've got to write a mapper, write a reducer, et cetera. So what we're finding more and more is that this is most useful for situations where you want to do some cleanup, some aggregation, some normalization. And then what the arrows show is just that there's adapters for EMR where you can pull the data, the analytics data, either out of S3 or out of Dynamo. That's natively built into Elastic MapReduce. And I think I kind of skipped over it, but going back for 1 second to the S3 example, and I've got this in the next slide. So the same way that I mentioned that you're going to be putting up maybe user-generated content or stuff like that into S3, that's a great place to just dump logs from the device as well. And I'll illustrate that in a slide or two. And so then our other option, which we announced last year at reInvent, is Redshift. And since this has been released, we've actually seen a huge uptake by gaming customers. And there's a number of reasons for this. First of all, it's SQL compatible. It just talks SQL. It's a Postgres driver. If you've got any off-the-shelf SQL tool like Tableau, Pentaho, et cetera, you can just point it to Redshift, run your queries against it. It's very similar to all of our other services. You pay by the hour, et cetera. And it, like EMR, has adapters for both S3 and Dynamo. Pull the data into Redshift, and then you can do your analysis from there. So let's look at what a Redshift example would look like. As I mentioned, simplest way to get started is you just want to write a file on the device, right? Every so often, you're just maybe time stamping something with some metrics, like, hey, how long has the guy played? What level are they on, et cetera. And then you're just going to upload that device to S3. Or more specifically, if you're using CloudFront, put it up through CloudFront, which sends it to S3. And then nightly, process that into Redshift. Redshift has built-in adapters to be able to say, hey, from this S3 bucket, pull this data, right? If we put it in a CSV format, you just say, hey, the delimiter is CSV, pull this data in. You take Tableau, you point that to Redshift, and you're done. So you can do a lot more complex stuff with this, but in terms of your just simplest low-hanging fruit, this is a bone-simple way to get analytics. It's really straightforward. Just save the file, upload it to S3, stuff it into Redshift, and move on. And then as your game continues to grow, you can add more interesting stuff. That's the last piece I want to mention about analytics, and then I'll wrap up here. So the other thing you might want to stick into there is server logs, maybe from your app tier, from your game servers. They're saying, oh, so-and-so is connecting from these different places, et cetera. Again, you stick them into S3, same as you're doing, right? You're just kind of stuffing it into a holding place, if you will. Run EMR on it, maybe do some cleanup because your logs that are coming off of your web servers are most likely in some kind of Apache format as opposed to maybe CSV or whatever you're writing on the device. So you want to normalize that, get that into one common format. You put that into Redshift. You can point your GUI to it, and you can run all your analytics. So it really can be this simple. Like this is not, I'm not trying to gloss over things with, oh, by the way, there's 6 other moving parts you would need, but you really can do it just with these few services. All right, so that's the content I have. I don't know if we have time for Q&A, but I just want to just kind of summarize. So free-to-play is going to continue being dominant for the foreseeable future. No indication that's going away. It means you've got to build a cost-effective infrastructure. You've got to be able to scale that out, as we mentioned. And do start small. Even though we went through a lot of stuff in the slides, you don't have to start with that endpoint each time. You can start with that initial game core backend with EC2, RDS, S3, and just kind of add these pieces, right? It's real easy to kind of rinse, repeat these patterns. Elastic Beanstalk, absolutely I would use that. Dynamo DB, absolutely I would use that. S3 with CloudFront for storing your static images and for optimizing it, getting that latency down to your end users. SNS to send out those push notifications to users. And then as you're scaling up, using SQS to offload background tests, using Elasticache in order to add scaling, and ultimately focus on the game. Use as many off-the-shelf services from us as you can. That would be my kind of recommendation to you. See how much stuff you can just use off the shelf, focus on just configuring a few things, and focus on making your game. And last thing I wanted to leave with you, I just wanted to kind of point you to some other talks I thought were interesting. I think they're going to be pretty cool to check out. There's some games on, talks on running high-performance ops. Red 5 is doing some great stuff in terms of managing a global server set. Killzone Shadowfall, already mentioned that. I would definitely check that talk out. They're going to talk about Beanstalk and also Dynamo DB. Parse might give you some insight on what it is like to build a service, because it's very similar. You're kind of building a game as a service, if you will, so it might be a good talk to check out. And then the SNS mobile push one is actually pretty cool. I know the guy who's giving this talk. They're actually going to do a demo in the talk. They're going to show you. They're going to run a Flask app in Elastic Beanstalk, show through a few configuration things, and be able to push a notification to your phone. So if you're interested in mobile push, definitely check that one out. And then other service-specific talks, I would say, if you have time, got a few Dynamo DB ones. The SmugMugs one I think is interesting. SmugMug always, sorry, spoiler. SmugMug always gives interesting talks, but this is how they move from MySQL to Dynamo DB. So if you're interested, but you're saying, well, I know how SQL works, MySQL, et cetera, look into that one. It might give you some tips on how you can kind of map those concepts. And then obviously, Elastic Beanstalk. If you're interested in caching, I'm also giving a deep dive talk on Friday about caching if you're still in town. And then analytics as well. Cool. So that's it for me. Thanks a lot. Appreciate you guys coming out. I think we might have a couple minutes for talks, Q&A. So cool. Thanks.